Good afternoon. As per my introduction, I work in the Roads and Highways team for the Origin Alliance as the Design Survey Coordinator. My role involves managing the 12D design team and obviously liaising with the surveyors on a daily basis, more than some than others. Today I'll be speaking about some of the experiences I've had managing the 12D design data on the Ipswich Motorway upgrade project. I've been using 12D for over 10 years now in a variety of work. Whether the design is a single road or an 8-lane motorway, one of the most important things that I've learned that is managing your 12D data is one of the most important things. This process starts from managing design standards, survey data, services, drainage through to roading layouts and working options. I'll be covering the process from the design team today and then hand you over to Mark Dave and Pete Watson from the survey team, who will be speaking about 12D field. I believe Mark has a live demonstration prepared, so hopefully he has a little bit more success than Alan has had. In early 2008, the now Department of Transport and Main Roads formed the Origin Alliance to deliver the detailed design of the Ipswich Motorway upgrade between Dinmore and Goodna. The Origin Alliance consists of 6 partners, including Main Roads, Abbey Group Contractors, Fulton Hogan, Seymour White Constructions, SMEC and Parsons Brinkhoff. The project started construction in June 2009 after federal funding was officially granted and is due to be completed in 2012 at a cost of around $1.95 billion. For well over 1.5 centuries, the Ipswich Motorway has catered to varying needs of local communities and played an important role in the growth of the Western Corridor. Early transport between Brisbane and Ipswich was mainly on horseback, with the first ever recorded coach trip in 1860. The old coach route followed almost the same corridor as the present motorway today. One of the constraints in the middle of the project is the site of the old Redbank rifle range. This range was used from as early as 1911 through to the 1980s. During times of war, it was used as a training grounds for troops. In the centre of the photo is some white concrete mounds and a shooting range at the end. Our project site is located in the middle of that. You'll see a little bit later on. I'll just go back a second. In the bottom left-hand photo, you can see the troops shooting up a concrete beam there. Those concrete foundations still exist today, and the firing mounds are fenced off within our site office compound, and that's a photo of the shooting mound at the other end. During the start of the project, there was quite a huge delay at the start. We had to remove all the UXOs, or unexploded ordnance, before any of the surveyors could go in there and survey. The project is located approximately 25 kilometres from Brisbane CBD and consists of 8 kilometres of motorway widening from 4 to 6 lanes and has a provision for 8 in the future. It also includes over 15 kilometres of service roads. The project starts at the time with the Ipswich Logan Interchange project, which is newly completed at Goodna, and finishes at the times with the Cunningham Highway, Warrego Highway and Brisbane Road near Dinmore. We have a few layout photos here of the proposed design from the urban design guys. This is the western end of the project. We've got Warrego Highway to the north, Brisbane Road to the west and Cunningham Highway to the south there. Currently there are some right-hand exits. The current design shows for is going to be all left-hand standard TMR exits off ramps. We've got Redbank Shopping Centre in the centre with Mine Street Interchange. We've got one of the Redbank Sports Complex down to the bottom right here and a couple of local service roads. We've got the Goodna Creek rehabilitation because the new motorway dropped over the old one and one of the on-ramps onto the motorway. And this is at the eastern end of the project at Goodna. We've got the Church Street Interchange and numerous pedestrian ramps. Including in this project, obviously there are some major interchange upgrades with new and improved pedestrian and cycle paths. There will be new road and pedestrian bridges built for cross-motorway traffic, with numerous connection roads to separate the local and regional traffic. Now, I think this is to take somewhat of the 80,000 vehicles a day that they have travelling through the site. A unique component of this project is the infilling of the abandoned coal mines in the areas of Redbank and Goodna to stabilise the ground. To undertake this process, this specially built concrete mixing plant was built. This tall white structure is visible on the southern side of the motorway and has been designed to produce the grout paste which is being injected into the old abandoned coal mines. The plant is capable of producing 2,000 cubic metres of paste product per day. It's transported to site in concrete trucks. The paste is then discharged under pressure into the base of the mines, filling the voids and stabilising the ground beneath the new motorway. We've got an aerial photo looking towards, probably in the middle of the project, looking east towards Goodna. You can see the old motorway with the proposed earthworks going ahead there. And then you've got the batch plant and site office with Redbank Shopping Centre in the bottom right. This is west looking west towards Dinmore. Again, you can see the site office and batch plant with the earthworks underway and the shopping centre in the back, top right. At the start of 2009, the Origin Alliance relocated the design and construction staff from the CBD to the construction site office at Redbank. This purpose-built complex allowed for better collaboration between the design teams and the communication teams. And I believe this has been beneficial for the designers to be able to step out on site at blink of an eye and go and visit the issues that's present on site. Currently, the site office contains over 350 staff, 130 of which make up the design team. So the design team comprises of the geotech, PUP, drainage, drafting and roading engineers. We've got, at the peak of the project, we probably had 10 road designers on board, so we had a combination of software users. The Ipswich Motorway corridor, as you can see, is incredibly constrained between numerous schools, houses, abandoned coal mines, shopping centres, and we couldn't really call it constrained if we didn't have a Queensland rail corridor to contend with. This was a couple of months ago, early December I believe, and it's a new side track, if you like, to push the westbound traffic across so we can start the motorway construction. So to get the this is where the detailed design project gets interesting. We split the road design across two different software programs, 12D and MX. Now I can only guess what you're thinking, but we managed to stay civil towards each other, and we worked together to create a complete model. Now I'm not sure who those two figures are, I'm sure one of them might be Lee. At the project startup, we investigated completing the design model in three ways. Firstly, it was the traditional MX environment, which has a long-running history in Queensland motorway design. But this was at the peak of the design demand in Brisbane, and we couldn't find enough experienced designers. Secondly, we looked at a complete 12D environment. Now, as we all know, 12D is new to detailed motorway design, and there are some people out there that I think I think we're looking to have some experience shown and some industry standards set. So we also struggled with obtaining some experienced motorway designers, 12D guys. So thirdly, we came to a combined environment, and this was to get the benefits out of both programs. Obviously MX has a long-running history in motorway design, and but we also wanted to look towards the future and develop 12D. The 12D MX split enabled the road team to overcome a few issues we encountered. One of them was resourcing. I mentioned that we struggled to get enough experienced staff in either MX or 12D. It allows to, we had the issue of the lack of experienced 12D motorway designs available within the industry, and also an unknown 12D capability on delivering a large detailed design motorway project. But on the other end of the scale, enabled the team to increase the 12D designers' knowledge in motorway design, utilise the skills to the best of their ability, so we used the the 12D guys what they were good at, and the MX guys as well. And it obviously increased our knowledge on 12D delivery capability on a large motorway project without the increased risk of completing the entire design in one package on such a tight frame time. So to get the two software programs to work together, we required a set of design standards that would work in both software programs. One of the main differences between the two software programs that is directly related to the standards is the string coding. MX has a 4-character limit, whilst 12D, as you all know, has a varied length of string naming, and there could be some wonderful names coming out of some designers. Our coding started with the standard main road string names with a review and expansion to allow greater design flexibility and to cover all aspects of detailed design. In addition to the standard 2-letter main roads coding, the 12D designers also had to ensure that the third character was referenced to the master control string was being applied from. So this allowed the MX designers to show the 12D design on their cross-sections without labelling it. So it was a little new for some of the 12D guys, designing ES as a edge of shoulder without any other name after. Plan plots were produced from both programs to the drafting team. Both had to look the same, so the combining extras could not be differentiated between. Initially we looked at using 12D to produce all planned long section and cross sections. This turned out to be a little more difficult, as tadpoles are one of the things that you sort of have to produce from a design, not applied to a design, so it was decided that we produce from each package. Long section and cross section plots also had to look the same. This was a little more difficult, as both programs have different restrictions on the placement of items. For example, the super elevation line in 12D can only be located at the bottom of the plot graph. Don't ask me why this was a problem, but it was at the initial start-up stage. Now the design interface, location was an ongoing decision throughout the project. In most cases, the 12D design controlled everything outside the verge string on the main alignment. This obviously varied if the main line wasn't interfacing with any 12D service road. It was obviously had its own interface, but the design interface still changes on a daily basis as we progress the final design. Capturing design changes has to be one of the most important items when completing any design. Both programs complete this in different ways. MX typically locates theirs at the top of an input file, whilst in 12D version 8 it's located in the description panel. On this project we decided that two different locations was not going to work, so we created an Excel and combined the two. This allowed us to differentiate between the two different design programs and allowed numerous filtering capabilities. So anyone can go into this file and see, pull up a designer by a date in a zone and see what changes had been completed. Now I think the text in the black has been issued to the surveyor, and the text in red is yet to be seen. This spreadsheet was also developed further to include model status, issues and comments, to include to the surveyors when they received our 3D model, so design lots could be tracked, and instead of receiving a complete model they got some idea about what road was at what status. Data sharing between MX and 12D was incredibly important, and considering MX was completing half the road design and 12D the other half. Design data was shared between the two programs on an unnecessary basis, and to make this sharing seamless and consistent for the designers, we created a 12D project, which is shown. It basically has a very simple process, opens up, cleans models, reads in the latest Genio, and saves and exits, so that that file was referenced to all 12D designers. So at any one point, the one update, which was run on a separate computer, could be updated, and everyone was looking at the latest data. The 12D master project that we set up as well had a very similar process for the MX team. They had, it would create a Genio file every time that the road design was updated to a complete model. These files were located in the same location every time, and this allowed the current design to always be in the same location and prevented old designs being utilised by different designers. Now, the 12B Master Project we set up combined the 12B and MX road designs, and from there we created a complete 3D model by creating a new model, cleaning, and very similar to I'll say an MX input file where they do a delete and recreate. We had a very similar process within the Master 12B project. This enabled the sharing to the PUP and drainage teams to have a complete road design model. This process occurred when the current design had been signed off, which meant that the road design model was to a level of finish that was acceptable for other teams to be designing off. Initially, in the early stages of the project, the design was developing rather quickly, and the drainage and PUP teams didn't like the design changing 5 times a day, especially when a road moved 5 metres. The Master 12B project also produced plan, long section and cross section plots for the 12B component of the project, so it meant that one project was open and we had the latest data at any one time. Model sharing from within the 12B environment was a little trickier than first thought. The 12B road design was split into 10 different design packages. This allowed for numerous 12B designers to be working on different parts of the project at any one time. Unlike MX, 12B projects sit on the network and are live. 12B obviously sits on the network. This obviously takes full advantage of its sharing capability. MX, however, can develop designs locally, then upload to the network for inclusion into their master input file, this allowing an output from the network at any time without the model being half completed. The issue we had with the Master 12B project was that the individual road projects shared data directly into the live project. This obviously meant that an output from the Master project at any time could result in a half-designed road. Now, detailed designs and detailed design area managers like to see the designs stable and not change on a click of a button. So one of the issues we had with this was that it was okay if you're already in the master project because you didn't have to synchronise the project that had changed if it was complete in the first place. But currently in 12D, all 12D projects synchronise automatically on startup. I believe this is somewhere where we could probably change in the future and have it as an optional feature so that it just opened the project and then you can synchronise on a click of a button. We investigated 2 options to overcome this issue. The first being that the individual road projects were to write a 12DA file to an input directory, and the master 12D project simply read this data in. The issue with this is the designer had to clean the previous models before reading the current data in, and then had to sort out which models went under what views. Now, in the master project, I can tell you there's a lot of models there. The second option, and the one that we're using to overcome this problem, is a 2-tiered folder structure. This is set up so that nothing is shared out of the live development projects, which is down the bottom there. What we do is we write a simple chain which writes a 12BA file from a view. This 12BA file sits in an input directory in a control project. The designer then has his her responsibility to go to this control project, run a chain which basically clean the project, read the latest data and then made it available for sharing. Now, the only real change you had to do in this project was if any new models were added, you had to actually go in and ensure that they're all shared. This meant that the master project then, unless models were added, the master project updated automatically, and the static design data was always a complete model. So, yeah, essentially then at any time we could really just output the XRFs, long sections, cross sections out of the master at any time without a road designer being halfway down the road and it coming through on master and the XRF being half finished. So one of the slight concerns I have with the Master 12B project is that when adding and removing models from the model list, there's no way of filtering or ordering the models that you have, so that for us we have a process in place that tries to tidy that process up, and that is to have remove all models from a particular project and then re-add them even if one model is out, that way that your model list didn't get complicated and messed up. So hopefully in the future we should be able to maybe order some the models shared into a project by clicking and reorganising them. Now, during the course of the startup, we developed a number of time-saving tools to help designers document and report the design consistently, so that sharing projects and sharing resources across would be seamless. The road design was set out from the start to have a very basic road template, which included basic road strings and shoulders. From there, we utilised UltraEdit's capabilities to insert multiple lines of code for standard components of design, such as curbs, walls and footpaths. We customised the UltraEdit display to allow the designers to visually see the command lines in different colours in the coding. As well as that, we had an insert template functionality, which we set up so that at any time, if you needed to insert a wall or a certain type of curve, you just double-clicked on the line of code, and it inserted up to 10 lines or more of code at one time. All it enabled was the designer to modify some string names and include the changes he needed. The coming to changes and string names, the find and replace capability was very powerful, and I can tell you when trying to find something in over 1,000 lines of code, it's a lot easier than scrolling through the current version 8 MTF. UltraEdit also has a compare function, which allowed the designers to compare old MTFs from current MTFs, and especially the options developed in the background, so that designers could have someone working at an option and then compare the two MTFs and then cut the design, hopefully cut the design simply into the current one. We utilised layout input files and defaults within 12D to help designers follow the correct procedures, and when outputting data for design reports, aquaplaning spreadsheets and site distance checks. I'll go back. This particular layout input file essentially helped with the output of the data to the aquaplaning spreadsheet that we had set up. Essentially it was a superstring, I think it was draped on the alignment and then reported at every metre. This allowed us to satisfy a TMR standard of checking that the depth change over a metre wasn't more than 5 mil. Macro we used was developed right at the start of the project by Mike Jensen. This helped us to produce intersection site distance checks and ensure that they were recalculable when the design changed. This particular function allows the user to check or produce SISD, ASD and MGSD site distance checks in relation to a control line, chainage and offset against a particular tin. You can see the list of functions along this road in particular. It was very easy to recalc those and reproduce the reports, and screen dumps were produced to go into the design reports at the request of the engineers. A great tool I'd like to see developed within 12D is to see the site distance reported in a graph-like function. This function allows the designer to see the deficiencies against certain design criteria. Having this dynamically linked to a plan and perspective view might be asking too much, but I have seen some of Mike's graphs and they look pretty impressive. So what we're showing here, I think, is the different design criteria down the bottom. So we've got 70 kilometres, 80 and 90 NDD targets, which are being grade adjusted. The black line shows the direct report of the 12D site distance report, just purely graphed, and we can see that certain components of that design can now be used for temporary traffic at 90 kilometres an hour, and it allowed us to then go back and see where we weren't meeting certain requirements. Change were used in both individual road design and in the master project in a number of ways to help automate the design and outputs. Batch files were also used within change to help supersede and move data before overriding. So one of the every live design data we had, basically when it was writing the output view to the control project, it ran this project first, which essentially superseded the design data, and then created a new project. So at any time, if the designer had made a mistake, they could always go back and read the previous control project's 12 and so that stuff up, so it didn't take too long to do a fix. On this project, we've been transferring the complete 3D model to the surveyors. This allows for the survey team to interrogate the full design with 12D field without missing design components. The issue with this is that the survey team often receive data that before it had been signed off and is always at risk of being constructed before being signed off. Before any data was sent to the surveyor, we verified it in a standalone 12D project. This 12D project reads in the 12DA and GNA files from essentially the master projects. This project ensures the data is complete and the file contains all the information that is required at the time of setting out. The 12DA file produced from this project is accompanied with the design changes diary, which allows the surveyors to interrogate the model and with detailed changes and highlights the status of certain roads. In the future, I think I'd like to see some way of being able to control, I think, the 3D model. It's a very open beast, if you like, in terms of how we look at controlling the 3D data to the surveyor. A simple way may be to highlight the design in green, orange and red to show items that are for construction on hold or not for construction. I'm not sure how this will be done, but hopefully the 12D programmers might be able to help out. Over the past 20 months on the Ipswich Motorway upgrade project, for me personally, it has been a huge learning curve on managing 12D data on such a large detailed design project. The key thing I can take away with me is that good organised data management is the key to success in any project. Thank you.